Hello once again, guys. Welcome back to another JLand Bio exclusive video. We're talking Chem 2, we're talking Video 5-2, we're talking Lewis dot structures. Now, I do not anticipate that this is too difficult for you guys. I know many of you have had this before. We're going to talk about a specific method to go through and complete those Lewis dot structures. By the end of this, you'll be able to complete a lot of more complex Lewis dot structures than maybe you have done in Chem 1. Now, your learning objective today, you should be able to draw the Lewis structure of any molecular structure. Whew. We've got quite a few vocabulary terms here, but again, these are all ones you've heard before. That includes Lewis dot diagrams, single bonds, double bonds, triple bonds, lone pair resonance structures, and polyatomic ions. Now, for an individual atom, when we look at Lewis dot structures, we remember that they are representations of the number of valence electrons that are present on that particular atom. The dots are representative of valence electrons that are present. So you should start at a side, add extra dots clockwise around each compass point, and if there are 5 or more dots, then you double them up on each side. So for example, this is oxygen. Oxygen has 6 valence electrons in its outer shell. Therefore, you will see 6 dots on the outside of a Lewis dot structure for oxygen. Pretty straightforward. Hydrogen would have 1 dot, beryllium 2 dots, boron 3, carbon 4, nitrogen 5, oxygen 6, fluorine 7, neon 8, etc. Now when we look at a Lewis dot structure, it is a visual representation of the structure of an atom or molecule where the symbol represents the elements, the dots represent electrons, and the lines represent pairs of electrons that are shared in a covalent bond. So typically when we look at Lewis structures, we are looking at items that are covalent. Can you do them with ionic bonds? Yes, but they do look a little bit different. So keep in mind, our whole goal here is to think about satisfying the octet rule, okay, or the duet rule if you're considering hydrogen, while keeping in mind the total number of electrons that are given by the individual atoms of the structure. Once these are all satisfied, you've drawn your Lewis structure. So how do I go about and do that in a methodical way that'll get me the right answer just about every time? Well, here are your 6 steps. They look long and confusing, but as you work through the process and you're able to go through and continue to do this, it actually becomes quite easy to build Lewis dot structures. The first step is to determine the type and number of atoms from your formula. So you look at your formula, look at what atoms are present, and then determine the number of atoms in there. From that, you determine the total number of valence electrons by adding them up. You determine the central atom of your structure, which is always the atom that has the lowest electronegativity. That is the one that is furthest away from fluorine. The only exception is that it cannot be hydrogen. Bond your other atoms to your central atom with single bonds. So you just draw a single line in between them. Add pairs of valence electrons to all atoms to reach the octet rule. So for example, if something has a single bond attached to it, that represents 2 electrons that are shared between that atom and another one. You would then add 6 dots on the outside of that atom in order to satisfy the octet rule. And you would do that for all atoms to ensure that the octet rule is satisfied. The last step is if the number of electrons in the structure is equal to the number of valence electrons, you're done. I mean, it's pretty straightforward and pretty simple. If not, you're going to need to remove 2 lone pairs of electrons and create multiple bonds in between the 2 atoms where you remove the lone pairs until the number of electrons in the structure and valence electrons is the same. Okay? A lot of complex terminology there, but in order to make this a whole lot easier, we're going to do some practice problems. So I picked a couple easy ones to start us off with. So we're going to start off with CO2. So the first thing is to determine the number of atoms that we have. So we have 1 C, 2 oxygens. Okay? Each carbon has 4 valence electrons. Each oxygen has 6. 6 times 2 is 12, so we need 16 electrons in our structure. Okay? Next step is to determine the central atom. We have carbon and oxygen. So if we take a look here, carbon is furthest away from fluorine, so that's our central atom. So we're going to draw that first. Attach everything to your central atom in a single bond. Add lone pairs to satisfy the octet rule. So if I look at this oxygen here, it has 2 electrons that are attached to it. It needs 8, so I'm going to add 6. Same with the other oxygen. The last carbon there in the middle, you're going to add 4 because it has 2 bonds attached to it for 4 electrons, so it needs 4 more to satisfy the octet rule. Now let's add up the total number of electrons and see if we're good. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we have 20 electrons in our structure. Well, that's not going to work. That's too many. So in order to do this correctly, what we do is we erase and add a double bond in between where we remove the two lone pairs. So now we go through and add them up. We get 2, 4, 6, 8, 10, 12, 14, 16, 18 electrons. That's still too many. So you could add a third bond over here, but it is more stable to have two double bonds than a triple bond. It has to do with the symmetry of the molecule. So we're going to remove two more lone pair and add another bond. So you see, as you remove two lone pair and add that double bond, it still keeps the octet rule satisfied. So once you've done that, you actually don't have to worry about it anymore, which is really, really nice. So now we go back and check it. 2, 4, 6, 8, 10, 12, 14, 16. I'm done and done. Okay. Let's look at HCN. Same process. H, C, and N. 1, 4, and 5. So my structure is going to have 10 electrons. Central atom again is going to be carbon. It's closest or furthest from fluorine, with the exception of hydrogen. Remember, hydrogen does not count in that rule. Add lone pairs to satisfy the octet rule. Now remember, hydrogen only wants 2, so it is already satisfied. So we just go through and add the rest. And carbon needs 4 electrons. Nitrogen needs 6. So we add them up. 2, 4, 6, 8, 10, 12, 14. 14 electrons does not equal 10. So we're going to remove 2 lone pairs. We count them up again. We have 12 in our structure, so we need to add another double bond. Now, remember, hydrogen cannot double bond because then it would violate the octet rule. So we're going to go through here. We're going to do a triple bond then, because that's going to be more stable than having hydrogen in a double bond. It is really hard to erase those electrons, just throwing that out there. So 2, 4, 6, 8, 10. Oh, I didn't erase that last lone pair. There you go. So now we have 10 in our structure. We're all good here, okay? Take your time, read through each problem. They will get more complex as we continue to work through them, okay? So, again, just keep that in mind. They won't always be this easy. They will get a little more complex as we move forward. Now, as you get better at drawing Lewis structures, you'll find that some structures can actually be shown with more than one Lewis structure. These are called resonance structures. And typically, it's a double bond that can move without changing the molecule. So if you take a look here, you have an oxygen that is double bonded and an oxygen that is single bonded. That is the correct Lewis structure for O3, which is ozone. However, that double bond could technically be on the opposite side of the molecule and still be correct. The reality is that it continually fluctuates between the one on the top and the one at the bottom. The one on the top occurring about 50% of the time, and the one on the bottom occurring about 50% of the time. If this is the case, you must draw all possible Lewis structures. So sometimes there are 2, sometimes there are 3. If that's the case, you have to draw all of them. Okay? Keep that in mind. Another example of a Lewis structure that we could draw is one that is a polyatomic ion. Remember that polyatomic ions usually have charges that are associated with them. If there is a charge, we add or subtract possible electrons. So for example, if there is a positive charge on it, remember that indicates the removal of electrons. So in that instance, we're going to subtract whatever the charge is to the number of electrons. If there's a negative charge on it, we're going to add, because negative charge indicates that there are more electrons that are in the molecule than are actually given. So we add those electrons to it. So here you have NH4. And you would think it would have 9 electrons, 5 from nitrogen and 4, 1 from each hydrogen. 5 plus 4 is 9. But because of that positive charge, it actually only has 8 electrons. When you draw your polyatomic ion, you need to place it in brackets and then place the charge on the outside. Yes, I will be grading for that. So make sure that you realize that if it is a polyatomic ion, you must draw it in brackets and the charge must be on the outside. Simple tips and tricks. Follow the rules in order. I'm not joking. The rules will get you there almost every single time. You just have to make sure that you follow those step by step. Don't skip rules, because sometimes you will make mistakes when you draw your Lewis dot structures. If you do get something that has multiple carbon atoms, they typically include a chain of carbons. So for example, on the right side here, we have 3 carbon chain. This is actually propane. It's C3H8. I'm Hank Hill, and I sell propane and propane accessories. Oh! It's as good as it's going to get, guys. Be sure to look out for ion charges to add or subtract electrons. Make sure you don't forget octet rules. Now keep in mind as well is that smaller atoms and noble gases don't always follow the octet rule. And we'll look at some examples of this in class. Hope you guys got what I needed you to get out of this video. Hopefully you were able to draw those Lewis structures. Hopefully this rings a bell to you. We will do some practice with this in class, and that's going to help us moving forward when we start talking about polarity of bonds, polarity of molecules, VSEPR theory, and intermolecular forces. Thanks, guys. Have a great day, and we will talk to you later. Bye-bye.